Voyager 1 is a human flight, the farthest man-made detector. Since its launch in 1977, has been in space for over 40 years. It has now reached the distance from the Earth, location 24 billion km. He's traveling at 17 kilometers per second. Fly outside the solar system. As time goes by, Voyager 1 will continue to move away from Earth, sailing further into interstellar space. So, why did Voyager 1 fly for so long? Where does his motivation come from? And how to avoid it? Collided with other celestial bodies. In fact, when Voyager 1 was launched, the fuel carried is extremely limited. It ran out of fuel in 1980. That is to say, Voyager 1 now, it flies without power and has escaped the attractive forces of the Sun. And the reason why travelers can operate without power, keep flying. In fact, it relies on the planet's attractive force slingshot, speed of effect acquisition. We know, an object wants to escape from the Earth, free from the attractive forces of the Sun. It is necessary to reach the third cosmic speed, that's 16.7 kilometers away. At first, Voyager 1 departed from Earth, only reached the second cosmic velocity. This means that Voyager 1 at that time, only freed from the attractive forces of the Earth, can't leave the solar system. And then through the planet's attractive force slingshot, the effect accelerates to get rid of the attractive force of the Sun. So what is the planetary attractive force slingshot effect? Planetary attractive force slingshot. The effect is to use the planet as an attractive force booster. Throw the probe towards the next target. We know that when the probe is approaching a planet, the planet's attractive force will pull the probe towards itself. Since the planets themselves are also orbiting the Sun, perform an orbital motion. And when the probe leaves the planet, this relative motion will allow the spacecraft to gain some of the planet's orbital velocity. Therefore, enough to accelerate the probe to the third cosmic speed. At that time, Voyager 1 took advantage of this approach, accelerated by Jupiter and then Saturn, reached 17 kilometers per second. Therefore, in the case of running out of fuel from the attractive force of the Sun, fly outside the solar system. So Voyager 1 is flying in space for so long. Why didn't it collide with other celestial bodies? Although there are many celestial bodies in the solar system, including planets, satellite asteroids and comets, but space is incredibly vast and sparse. The distance between celestial bodies is millions or even billions of kilometers to calculate. For example, the asteroid belt that exists between Mars and Jupiter, although it contains millions of asteroids, but the average distance between them, at least 500,000 kilometers. That is to say, the average distance even exceeds the ground jump distance. So the probe is flying. The probability of colliding with these celestial bodies is extremely low, and with Voyager 1 into the vastness of interstellar space, the density of celestial bodies decreases further. The distances between celestial bodies are even greater. And in this environment, Voyager 1, the risk of colliding with celestial bodies is almost zero. So Voyager 1 can't possibly communicate with other celestial bodies collide. However, after 2025, the nuclear battery carried by Voyager 1 will run out, then stop working. Then he will lose contact with the Earth completely. Become the silent surname of mankind. Because on Voyager 1, also carrying a gold disc, it contains sounds and images from Earth. About 17,000 years later, we'll fly out of the solar system with this information. About 40,000 years to reach the next star system.